start actually with Gilt Group and Michael Briztek, who's the CTO and founder. And Shopaholics in the audience are probably already familiar with the Gilt Group because, as well as Jet Setter and Gilt City, and it's a great way to find really good deals on really high-end stuff. And obviously, I know that the Gilt Group is expanding into some other areas too. But Michael, if you just wanted to maybe tell us a little bit about what you've been working on and what it's like to be at one of the hottest websites out there.
Thanks, and thank you very much for that beautiful shot of those platform shoes. It turns out that you can sell a lot of shoes in a few seconds. Is people generally familiar with Gilt Group? Yep. So one of the main things at Gilt, when we started the company, it was mid-2007. We chose Ruby on Rails and Postgres monolithic stack. And the basic business model is try to do everything to bring all consumers to the website at noon to buy great products at great prices with limited quantity. And so what happens is everybody shows up at exactly noon, and they all try to buy the best things. And you very, very quickly end up in a world where you have a lot of traffic, and the traffic becomes hard. And at the end of the day, it's transactional, it's e-commerce. If you have 1,000 pairs of shoes on a particular day, you want to sell exactly 1,000 pairs of shoes. Not 1,001, not 999, exactly 1,000. And so then the question is, how do you do that and do it in a period of time when the company is growing relatively quickly? So if we skip forward just a couple of slides, that's marketing for the company. So the 10,000-foot view of the architecture, I think that. I think the main takeaway here is as we were growing, you start to see stress in different parts of the system. For us, it really followed the transactional funnel, so people coming to the site, logging in, trying to put things in their cart, trying to check out. I think the key takeaway from this is that when we started looking at alternative solutions to handle the traffic, they fit into different parts of the system, right? It's not taking the entire system, throwing it away, rewriting it, and hoping that it's magical. It's really, our approach is really look at the overall system, where's the traffic, where's the business growing the most, where are we feeling the most pressure, and then reevaluating how do we get ahead of that growth and do it in a way that we can actually scale nicely. So when we think about NoSQL, for us it was a lot of what's the actual raw response rate that we can handle, will it scale horizontally, and in our world we think a lot about variability as well. So what's the variability in response time becomes really important, and we'll come back to that. As we started scaling out Gilt Group, we did what I think many other startups did, we'll just cache the data, right? And so we started going to this approach of caching all the information. There's a product called Memcached, which is quite good at caching, and we started building out the infrastructure that way. And what actually ended up happening is, then we wanted to do things like start personalizing the experience and making the experience better for individual customers, and that became really, really hard. And we had a system where we had caches. How do you invalidate data? How do you manage your caches? Do you have enough RAM? What happens if the cache crashes? Can you recover, et cetera? And that started to get pretty complicated. And so our approach at Gilt Group was basically pretty simple. Said caching's too hard. We tried that. Let's stop caching. And to stop caching, it means how do you make your data available, accessible? And if you could do that, it turns out the systems get a lot simpler. And so if we go forward one more slide, here's an example of where we ended up with a shopping cart. Version 1 of the shopping cart is in the database, a transaction to make sure that we didn't oversell. This is what it basically looks like today. You have a shopping cart, you access it from the browser, you go through a load balancer, use a product called Zeus. Then there's a bunch of app servers. We call them cart service because they provide the cart. They then talk to a cluster of key value stores. So we call those the KV stores at Gilt. And what the KV stores is an app server that speaks JSON over HTTP and uses Voldemort internally. And so you basically talk with HTTP, get, put, and everything's a document. And really what this allowed us to do is you can scale your data storage layer now horizontally, kind of any number of nodes. Today, Voldemort, like some of the other products, have support for distributing across data centers as well. And you can do it with simple load balancing. You can talk to any node in the cluster, and each individual node will then take care of distributing the request to the right nodes that actually have the document that you're looking for. And one of the big things we look for in Voldemort here was you get high availability for this. You have no single points of failure, but you also, with the Dynamo systems, you can actually drive down the variation or the variability in response time. And that's one of the things that we really hate in the relational world, right? You can have really, really fast performance, and then all of a sudden a query takes a minute. and what happened. And you have no idea. Maybe the backup started, maybe somebody's issuing a reporting query. You have no idea what just happened. But all of a sudden you have a problem. And one of the nice properties of the Dynamo systems is the fact that they distribute the requests in parallel. And you get to control the semantics over how many of those requests are you willing to block for before you respond to the client. Allows you to take your response time curves, which usually are jagged, and really drive down the variation to the customer. And for us, that was really, really important. So as an example, on our cart, I think when you put something in your cart, we store 3 copies of it at Gilt. When you ask to read your cart, we take 1 copy. Like the first one that comes back will show you your cart. And that lets us we optimize on slight potential for dirty read, but the cart's really, really fast. And eventually, if you don't like what you see, put it back in your cart, click the cart again, and 1 time out of 1,000,000, you might get a dirty read. And then when you move into checkout, we can choose different semantics and say, here we're actually charging your credit card for an order. We're going to store 3 copies of that order on 3 different machines. And whenever you read your order, we're going to require 2 of them to come back. And so there we can say we're willing to survive the failure of an individual node, but we're going to guarantee that when we charge your credit card, we will absolutely not lose your data. And in exchange, we're willing to make that request, that transaction, a little bit slower, both on the write and also on the read.